In today's video, we're going to be talking about section 3.3 and 3.4, so it might be a little bit of a long one. So in this one here, we're first going to talk about the angle addition postulate. So I know we talked about the addition postulate with segments, right? When we kind of had betweenness, in a sense, is where we were going with when we had a segment. But so when two angles are adjacent, that means they are next to each other. They have a common vertex and they share a common ray, right? And so they have no common interior points. So for example, what that means is, let's say I have this angle here, RSP. That point M is only inside of that angle. It is not inside of the angle PST. Okay, so that's what it means by no common interior points. So if we know that P lies on the interior of our angle RST, then we can say that the angle RSP, the measure of angle RSP, plus the measure of angle PST, will be equal to the full angle. So for example, if this is 30 degrees and this is 30 degrees, the entire angle will equal 60 degrees. All right, so moving on to an example here. So it says set up the equation using angle addition postulate, solve for x, and then find the measure of each indicated angle. So I'm first going to go ahead and write out everything I know. So the measure of angle APC, so that's the big angle here, is equal to 87 degrees. Then we know the measure of angle APB is 4x minus 12 degrees. And our angle CPB, right, CPB is 3x plus 21, or 22. At any point, pause the video so you're able to jot down these notes as well. Okay, so then we have here, we know that if I do the measure of angle APB plus the measure of the angle CPB, it will equal the entire angle of the entire measure of the angle APC. So I'm going to go ahead and plug in everything we know. So we have 4x minus 12 plus 3x plus 22, right? And so I'm taking this angle is here, and then we have this one over here. Okay, so we know the whole entire thing is going to be equal to 87 degrees. We're going to go ahead and solve. So here we will have 7x plus 10 equals 87, 7x equals 77, x equals 11. All right, so we have x equals 11. Now we have to go ahead and plug it into our angle. So we have 4 times 11 minus 12, and we will have 3 times 11 plus 22. And we will get here 44 minus 12 is going to be 32 degrees, and then we're going to have 55 degrees. Notice here how I put this little circle up here. You must put the degree symbol when you are talking about a degree. I did not do it. Notice I did not do it for x. X is just the missing variable. It is not a degree. All right, so then we're going to go ahead and move on to the next new vocabulary, angle bisector. So I want to reference before, remember when we had a segment bisector? So when we had a line or a ray bisecting a segment, cutting those two smaller segments in half, making them even. It's the same thing for an angle bisector, except we know the segment bisector gives us the midpoint, right? So this would be a midpoint. The only thing that's different is the angle bisector. It does not give us a midpoint. It just jumps all the way to giving us two congruent angles. So we can say that the angle APB or ABP and the angle PBC are congruent to each other. We know here that the ray BP is bisecting, so it's cutting it in half. Okay, so this ray here, BP, is cutting it in half. And you'll see here in black, there are these little arches. These arches are the tick marks that tell us what is congruent. Now, sometimes we might have an angle, for example, that'll be something like this, where it'll have 2 tick marks. And that's okay. It's just showing that those two angles have the same identifier to show that they are congruent. So in this example, we're going to go ahead and find our missing parts. So the first thing, always the first thing you do is you want to draw yourself a picture. We have this ray, this is a ray, and this is an angle. It is going to be bisecting our angle, cutting it in half. So first I'm going to start with the angle. So PQS, PQS, and then we have the ray QR. So I know I'm going to go to Q and then we'll have an R here. Now it says it's bisecting, so it's cutting it in half. So I know that these two will be equal to each other. We have PQR, so it's 3x plus 24, and then RQS is 5x minus 6. So here, since we know that they are bisected, we can say that the angle PQR is congruent to the angle RQS. So then the measure of angle PQR is equal to the measure of angle RQS. So then moving forward, I'm going to plug in what we know. So we have 3x plus 24 equals 5x minus 6. From here, we will then solve. So when we go ahead and solve, we will get, looks like we get a 30 and equals 2x, x equals 15. All right, so our x is 15. And then at this point, we're going to go ahead and plug in 15 into each angle expression. So PQR is 3 times 15 plus 24, which when we do that, we get 69 degrees. Notice I put the little degree symbol above. Over here, RQS is 5 times 15 minus 6. Again, I want you to notice we get 69 again. So here, these two are equal to each other. I did not have to plug it into both of them. I could have just plugged it into one of them. Now the next one here is asking for the entire angle. Okay, so the measure of angle PQS is the whole angle. So this is when we're just going to add our two angles together. So we're going to do the measure of angle PQR plus the measure of angle RQS, and that'll equal our full angle. So we will get 138 degrees. And then the last question is asking, is our angle PQS acute, right, or obtuse? Well, our angle is greater than 90 degrees, but less than 180, so it is obtuse. All right, moving on to the next. Here are a couple examples that I would like you guys to go ahead and try. I will get those filled in for you guys later, but right now I'm going to move on to the next ones. As you notice, I labeled up top angle addition postulate. So this is the first example I gave you guys, and angle bisector is the second example I gave you guys. So please use those to help you. And if you have questions, we'll talk about them later. Okay, the next part of the notes, here we have angle pairs. So over here, angle pairs, we talked about one pair of angles is the adjacent angles. Adjacent angles are when a pair of angles share a vertex, a side, but have no common interior points. Remember when I said if I put a point here saying M, it's only going to be inside of the angle APB, not in the angle BPC. Okay, so adjacent means next to. It's like you're adjacent to the door, adjacent to your friend. So here those angles are next to each other and they share this ray PB and the vertex P. Okay, so notice in here when we're looking at the names of the angles, we have PB and BP. If they're adjacent, they will both have two of the same points. The next angle pair we have is a linear pair. A linear pair was what it sounds like. Linear means line, and we have a pair of them. So a pair of adjacent angles, because yes, they are still sharing a ray. The ray, so here in this case, it's ray VC, and they have the vertex is the same V. So, and with no common sides, let me rephrase that. The non-common sides are opposite rays. So as we talked yesterday and the day before, I'm sorry, not yesterday, on Monday, VA, so we have VA is an opposite ray to VB. So that's what it means, the opposite rays. Okay, so they're angles that are next to each other. Linear pair, which we will talk about at some point later a little bit more in detail about what it gives us. But if you notice, here we have AVB. We know the measure of angle AVB is equal to 180 degrees. That's a straight angle. So we're going to be using that to help us as we move forward here. Okay, so we have here, recap, adjacent angles are just two angles next to each other. Linear pair is specifically, yes, they're adjacent angles, but more specifically, who they have non-common sides that are opposite rays, right? And so we know that it has that straight angle that's going to be 180 degrees. So I'm going to go ahead and do some examples with you here. So it says use the term adjacent angles, linear pair, or neither to describe these angles. All right, let's fix that here. So adjacent, linear pair, or neither. Okay, so angles 1 and 2. Angles 1 and 2, yes, we have this line here, right? We have that line, but they're not next to each other at all. So here we're going to have neither. Next, we have these angles 1 and 2. They are sharing this side, but they do not have non-common opposite rays. The opposite rays would be down here below, but it's not where those angles are. So here we would just have adjacent. All right, and then next one, oh, this is a good one. Okay, so this one here, we have the 1 and we have 2, but notice how they're on this same line here, and the only thing that they have now is just this ray in between them. So here we are going to have that linear pair. Okay, so it has adjacent angles and the sides are non-common opposite rays. All right, let's go ahead and do this example together. So here we have a linear pair. Okay, a linear pair, we know that it'll give us a straight angle. So then this line here, right, this line, the total is going to be equal to 180 degrees. So if we go ahead and use our angle addition postulate, we can say 4x minus 25 plus x plus 5 equals 180 degrees. Okay, so we can go ahead and say that equals 180 degrees. Now I'm going to go ahead and solve. So here we're going to have 4x plus x is 5x, negative 25 plus 5 is going to be minus 20 equals 180. 5x equals, I'm going to add that over, we're going to get 200. 5 divided by 200 is x equals 40. Okay. All right, so here we are, the next example. I am going to do this example just because it's a little different. So it's saying here we need to find the measure of angle of x, and it says that our angle ABC is a right angle. So we put our tick mark here. As we talked about, well, if that angle here is right, this one is going to be right as well. We know that this line here is equal. This line here is equal to 180 degrees. If we know that our angle over here is going to be 90, we can say 5x minus 16 plus 3x plus 42 equals 90 degrees. Okay, so then from here, we also, okay, so or what we can do is we know if this is 90 degrees, we can do 90 degrees, right, plus 5x minus 16 plus 3x plus 42 equals 180. When we subtract that 90 over, it'll just get us right back to here. So either one will be fine. And when we go ahead and solve, we get x equals 8. And that is that example here. So the rest of them are blank. I would like you guys to go ahead and fill these out. If you are still struggling and still would like to hear this lesson again, you can tune in tomorrow to the live lesson for our class. If you can't make it for our class period, I teach first, second, and third period. All right, thank you.